All right, here we go, guys. So now we're just practicing with all the stuff that we already kind of know. Or hopefully we've mastered it. So it says here, example one says, these are notes 35, area of subregions. It says, find the area of the region R in the first quadrant that is bounded above y equals square root of x and below the x-axis and the line y equals x minus 2. So everything here that you see pictured, they want the area. So knowing what we know, here's one way. You can do this in two separate integrals. You can go integral of this blue region, which is just going to be integral from 0 to 2 of the square root of x dx. And then I'm going to write plus, and then integral of this red region, which is just upper minus lower. So I'm going to go integral from 2 to 4. And then the upper is square root of x, and then the lower is x minus 2, and then dx. See? It's a lot of tedious little calculations. Let's suffer for a little bit, and then after we suffer for a little bit, we'll just use our calculator. So let's see. Real quick, guys, if I distribute this guy in red will be integral 0 to 4 minus x plus 2. So I'm going to write square root of x minus x plus 2 dx. That's what that is. All right, here it is, the one in blue. Okay, I'm going to go slow. I'm going to the one in blue, guys. This is the same thing as x to the half. There's no need for u substitution. We can just do the antiderivative of that. X to the 3/2 divided by 3/2, which is the same thing as 2/3. This is evaluated from 0 to 2. Plus, that plus is this plus. Let me go ahead and do this one in red. Let's see. There's more than one term here, so I'm going to put it in brackets. That's going to be the same thing. 2/3 x to the 3/2. And then I have minus x, so minus x squared over 2 plus 2x. Close that bracket, put a little lower limit of 2, upper limit of 4. That's all the calculus. The rest is just arithmetic, which I guess maybe could be algebra, upper minus lower. So here it is. The 0 we don't care about, 0 to any power, except 0 to the 0, but that's different. We'll talk about that. That's indeterminate, right? So I'm just going to plug in a 2. So 2/3 2 to the 3/2. Chop, how do I do that? You take the cube root of 2. You do the cube of 2, so 2 to the 8th, and then I do the square root. I don't remember having a square root on these. Oh, I can already see it's going to cancel. Okay. I'm going to leave it like that because I just see that it's going to cancel. Plus, and here we go, giant bracket. I'm going to do upper minus lower. So I'm just going to plug in a 4. 2/3, 4 to the 3/2. And then 4 squared is 16 divided by 2 is 8. So minus 8, parenthesis, big parenthesis there. And then 2 times 4 is plus 8. Plus 8, close, minus parenthesis. I'll wait for you guys to catch up. The 2/3, so I'm going to write 2/3 times 2 to the 3/2 minus, let's see, 2 squared is 4. 4 divided by 2 is 2. And then 2 times 2 is 4. Make sure that I'm not making any mistakes, guys. As you guys saw yesterday, I made a mistake. Okay. Now we have to add all this up. Here's what I see. I see 2/3 2 to the 3/2. That's going to cancel with a negative 2/3 2 to the 3/2. So out. See, because that negative you got to distribute. And I see these 8s 0 out. Let's see what I have. Let's see. I'm just adding them up now, guys. The square root of 4 is 2, and 2 to the 3rd is 8, and 8 times 2 is 16. 16 over 3 minus, let's see, negative 2 plus 4 is, this guy right there is a 2, so minus, is it just minus 2? All right, so I'm going to turn that 2 into 2 times 3, 6 over 2. So 16 minus 6 is 10. So 10, 6, not 6 over 2. Dang it. 2 times 3. Oh, yeah, it is 6 over 3. 6 over 3 is 2. 10 minus 6 is 10. So 10 over 3. That's my final answer of all this. 10 over 3. Kind of hard, kind of tough. The arithmetic was the tough part. What do you guys think? Tell me. Oh, the calculus part was just doing integral to find the area under that curve. I'll say it again. Yeah, guys, I color coded this. I didn't. This is not my illustration, but the stuff in blue is this integral in blue. The shaded region in red is this integral in red, and then I just added them. Does that make sense? Okay. Check it out. Is there an easier way? Go to the next example. It's the same example. That's because I want to show you something. Is there an easier way to find the area under this curve? I want you to notice. I want you guys to notice. Look, everyone look up here real quick. I can find the area under the square root curve from 0 to 4, that in red, and subtract this area in green that looks like a perfect right triangle. Do you guys see that? So I could have just done, look what you could have done, guys, and that would have made life simpler. I could have just gone integral from 0 to 4 of the square root of x dx and just subtract area of green triangle. See? Let's see if that would have been easier, guys. Let's see. Antiderivative of x to the half is, again, x to the 3/2 divided by 3/2, which is the same thing as 2/3. I'm going to evaluate this from 0 to 4. So let me do this part, just this part alone. We don't care about the 0 to anything is 0, but the 4 there. So 2/3, 4 to the 3/2. So let me help you with this, with exponents. This is an algebra skill, guys. So whenever you have an exponent, evaluate what you think is easier. You can do the cube first, and you can do the square root first. The 2 means square root. So the square root of 4 is 2, and 2 to the 3rd is 8. And then 8 times 2 is 16. So this is going to be 16 over 3. All right, and then let me write the area of the triangle here. Area of triangle. See, I'm color coding it. The gap between the base, between 4 and 2, that's 2. So 1/2 base times height, 2. And then the height is 2. So 2 times 2 is 4. Half of 4 is 2. So this is 2. OMG, guys. Oh, I don't want to do a linkage error. I was about to put -2 there. That's something that you guys do often. You guys just tell me, you just go -2. Guys, start a new line, because this equals 16 over 3. So here it is. New line. 16 over 3 minus the green stuff, 2. All right, well, this 2 is just, what do we say, 6 over 3? OMG, look at that. We get the same answer. I thought that was a lot easier. Did you guys think that was a lot easier? Yeah. All right. Don't worry, we're gonna come back to it one more time. Oh, look, guys, we're doing Riemann sums again. Oh man, I hope I'm not getting sick. All right, guys. Notice, relax. Notice those are not dx's. This is not a dx. That's a dy. So we can integrate with respect to y, guys. Look, that's a dy. The gap from here to here, that's dy. See the difference in y's. So we're going to start adding up an infinite amount of rectangles. Don't worry, we're not going to do the sigma notation. We can come by after school if you want to do sigma notation with y's. But I figured now that we're good, I think it makes life easier if we just go right into it. So now, notice we're going to integrate with respect to y. Chav, how do I know which one's bigger, which one's smaller? Because how we do upper minus lower. When you draw a vertical line, the bigger one is always the one on the right-hand side. This minus this. So notice, look, this is with respect to y. There's a dy. Notice that it says fy minus gy. Because this graph here is fy. This graph here is gy. Right minus left. Child, why is it right minus left? In a number line, the one on the right-hand side, 7 and 2. If I want to know this gap, you go 7 minus 2, right minus left. Do you guys see that? Okay, so from now on, there's your rectangle, rightmost minus leftmost. Draw a vertical line, right minus left. We're going to do an example. Oh, what example we're going to do? That same one. We already know this answer is 10 over 3, guys. We're doing Riemann sums. We're adding an infinite amount of rectangles, but they're not dx's, they are dy's. So check it out. Here's what you need. If these are dy's, I need my expression in terms of y. So I need to have x equals something. So first, before you do anything, y equals square root of x. This was y equals, what was that equation? X minus 2. I guess we could have just looked at it and figured it out just looking at it. All right, ready? I need to get it in terms of y. So that means x equals. So I'm going to square this because I got to get rid of that square root. And whatever you do to one side, do to the other. So that guy is just x equals y squared. Cool or not cool? All right, here we go. This one, just move that 2. So this one is just x equals y plus 2. I'm going to need this. I'm going to need that. I'm going to draw a vertical line. You don't have to, but this is just good practice. So here's my rectangle, right? So I guess let me just draw the rectangle because I don't want to confuse you. This is the line that's on top, quote unquote. This is the line or the curve that's on bottom. So my limit, my integrand, how's it going to look? It's going to look like this. Integral. I guess first let's put the top line. So parenthesis y plus 2, close, minus the bottom line, y squared, close. Did that make sense? Tell me, guys. Tell me. I can't read mine. Upper minus lower. I need this in terms of y. There it is. X equals y plus 2. Y plus 2. That turns into y squared. I haven't put limits. I'm adding them up in terms of y. Because boom, everywhere you go, no matter how you slice it. Hey, relax. It's Friday. No matter how you slice it, bam, 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 bam. That line's always on top, quote unquote. In terms of x, no. In terms of x, we did it in terms of x. It's this one.
I'm sorry, in terms of y.
In terms of y, we're still doing the area, but the area under that curve, top line minus bottom line. It's just in terms of x, in terms of y, nothing. You could have said this was x actually, now y, upper minus lower. So we're adding much, but now we're doing it with section y instead. It's a different way. To show you all the different ways. Because then later on, you're going to have figures that it's easier to do it in terms of y. You'll see. All right. All right, guys, come back. Are those, let me reemphasize, are those infinite rectangles, are those dx's or dy's? So I need to have it in terms of y, my limits. What's my lowest y value? 0. What's the highest y value? 2. And it makes life easy because you don't even have to worry about the 0 now. Check it out. Here we go. Integral. Now remember, we already know the answer. We better get 10 over 3 again. So integral 0 to 2, and I'm just rewriting it. Negative y squared plus y plus 2 dy. Put giant parenthesis on that if it helps you. Because you're just a rectangle. You're just adding an infinite amount of rectangles. Equals antiderivative of y squared, negative y cubed over 3. Antiderivative of y plus y squared over 2. Antiderivative of 2 is just 2y. All three of those terms from 0 to 2. You don't care about the 0 because 0 and all of those is going to be 0. So all we got to do is plug in a 2. So let's see what this answer is. Negative 2 to the third power over 3. It's going to stay negative, that part. Plus 2 squared is 4 divided by 2. Plus 2 times 2, 4. Upper minus lower. We have this discussion almost all the time. Fundamental theorem of calculus. Upper minus lower. Okay. 2 to the third power. Negative 8 thirds plus 6. OMG, guys, look, we got the same thing.
No way.
6 times 3 is 18. So 18 over 3, that's what that is. Get a common denominator. And then look, negative 8 plus 18, 10. The areas better match because all of the areas are the same. You're going to see, guys, we're going to do a free response question from AP that it was with Y that we have to do it with. All right, we're gonna use our calculators. We're gonna use our calculators, guys. All right, guys, focus. We're gonna use our calculators. Let's go ahead, guys. Let's go ahead and take out calculators. If you don't have one, please take one out. All right, here we go. Yeah, you're gonna need your calculators, guys. Take out a calculator. Those slimmer calculators are faster than the bulky ones, so always get the slim calculators. They have fast processors. All right, here we go. No, we're not. Miss, stop. Look, I'm a big guy, so stop. All right. Man, you guys are just bullies, man. Just you see weakness and you attack. Find the area of the region enclosed by the graph y equals x cubed and x equals y squared minus 2. So here it is, guys. This is the region they're talking about right there. Relax. We're not going to do all the heavy computations. We're going to let the calculator do it for us so we don't. So here it is. So look what they did. Y1, they just typed in x cubed. On y2, you're going to type in the positive side, so the positive square root of x plus 2. And on y3, they're going to type in the negative one, negative square root of x plus 2. Chop, I don't know where those are coming from. They solved for y on that expression. X equals y squared minus 2. They move the 2 to the other side. Y squared equals x plus 2. Chop, you didn't write it the right way. It's x plus 2 equals y squared. I like to have the y squared on the left, guys. Square root, y equals plus minus square root of x plus 2. That's what creates that parabola that's opening up in the x direction from conics. Yay or nay? All right, so that's the first thing I'm going to do. I'm going to type those three into my calculator. Y1, Y2, Y3. Y1. I already forgot it, man. Short-term memory. X cubed. Yeah, help me out here. X cubed. I need to get some sleep. Square root of, what was it? X plus 2. And then the other one's negative. All right. I'm going to make my window like theirs. So it's a square window, negative 3 by 3, negative 3 by 3. So here we go. So window, negative 3, enter 3, and that's a scale. So leave that as 1. Negative 3, 3. And voila, there it is. I love it. Everyone try it with me, guys. Everyone try it. Okay, remember what we're doing. Let's first do it. Let's first do this with respect to x. So let's see. Let's see what's on top and what's on bottom. So here it is. I'm color coding it. So with respect to x, I'm going to need two integrals. This one in purple, upper minus lower. And then once I pass that, I'm going to need this one in green, upper minus lower, all the way until I get to those intersections. So let's see. What's on the top? So let me go ahead and write this. I'm gonna color code it, guys. So here it is in purple. Integral. What's on the top? The square root of x plus 2. What's on the bottom? It looks like the square root of x plus 2, but the negative one. Minus negative square root of x plus 2. dx. My limits. What is the leftmost limit? Well, because of the x plus 2, that's going to be a negative 2. And I need this a there. That looks like it's negative 1, but let's make sure. Second, calculate. I need this intersection between the blue and the black line right here. Second, calculate number 5. Enter. That's not the curve. Enter. There it is. Guess there's only one intersection. Just push enter. And yep, it is negative 1. There's no need to save anything on the calculator. From negative 2 to negative 1. All right. We're just doing it with a calculator. We're not even gonna. That's just the purple stuff. I still need the green one. Here we go. I'm gonna change my marker to green. Plus where that one begins or where that one ended. So negative 1 all the way to C. All right, I need to get that intersection. So let me get it real quick. Second, is it a perfect one? Nope, it looks like it's off. Second, calculate number 5. And let me move. What curve am I on? Yep, the blue one and the red one. Yep, enter. Guess, nope. 1.2148. So I'm going to come to my home screen here. You see what letter they're using? So I'm going to write C here, and I'm going to put C. I'm going to define what C is. C equals, and put as many digits as possible. 1.2148623. You guys help me out. 1.2148623. Put as many digits as possible for the reader or whoever's grading it. And now you don't have to say that number anymore. You can just say the letter. Do the same thing with your calculator, guys, so you don't mess up. Chav, how do I do that? Go to the home screen. If you push X, look, there it is. Because it's right now it's saved at that register. So I'm going to go X, store, and what letter am I going to use? C. Every time I use C, that's going to be the letter that's on my calculator. Isn't that cool?
Wait, no. You gotta do that again.
Okay.
I don't see no store.
Okay. It's right next to the number 1.
Okay.
So push X, and then the store button is next to the number 1. And then save it to C. Push alpha C. And now every time you push C, that's the button. That's the value. Okay, so I got that in there. What do I need now? Which one's on top? Which one's on bottom? Okay. Which one's on top for the green one? The square root one. So I'm going to write square root of x plus 2 minus, and now the cubic is on the bottom, minus x cubed dx. For the green one, right? Okay. You're not doing anything by hand, guys. Everything is with a calculator. Where do I have the square root of x plus 2? In y2. Where do I have the negative 1? On y3. Where do I have x cubed? On y1. So on the calculator, okay, and then time out because there's always one that does it. Guys, on any exam, not just AP, any exam, do not do -2, -1, y1 minus, or I guess in this case, don't use calculator language. That's what I'm trying to say. y2 minus y1. Like, see, because it's not defined in the stem of the problem. And I guess you could define it and then have them, but like, do you guys know what I'm trying to say? Like, don't use calculator language. It even tells you on the AP exam, like, don't use calculator syntax. So use, like, if they don't name them, use the function itself, the expression itself. Cool or not cool? Okay, this is just for the okay, here we go. Let's find it, guys. So I'm going to go second screen. Here we go. Here's my screen. I'm going to go math 9 from -2 to -1. I'm going to see if I can do it in one shot. And then it was the square root, the positive one. So I'm going to go to alpha trace y2 minus, and then it was the other square root, but the negative one. And I have that one on y3. X, don't push enter yet, plus math 9 from -1 all the way to what letter? C. Remember, we started earlier, so there it is. There's my C. It hasn't changed. Check it just in case. And then what was on top? The positive square root, so the y2, right? y2 minus, and then the x cubed. So the x cubed was on my y1. If I didn't make any mistakes, which I hope I didn't, here's my answer. Mine's a lot faster than yours. Yours will probably take a little bit. The thick calculators will probably take a bit. 4.21494 is what I got. 4.21494. Okay, let me show you. Sabella. You gotta ask me. Look, I heard you. I got you. So you see in this part, like how you get your C? So did you do second, calculate number 5, and then it's telling me what curves to pick. So the blue one, the red one, yes, and then when it says guess, push enter. Did you get that value right there? Hey guys, ask me. I can't read minds. I can hear you. And if I hear every now and then, like, oh, you didn't get this, then, you got to tell me, guys, because I can't hear. All right. Whew, that was tough. Okay. I'm going to erase this. You guys ready? Look at this. Instead of all those integrals, we could have found this area by integrating with respect to y, because if we integrate with respect to y, the cubic is always on top, and this parabola that's opening in the x direction is always on bottom. Do you guys see that? So we're going to do a hack, because the calculator can't integrate with respect to y, right? Quote unquote, like it has to do x. So here it is. Look, check it out. So look, and I already have my equations. X equals y squared minus 2 and y equals x cubed. So here's my cubic. This one's the one that's on top if you do it with respect to y. And this one's the one that's on bottom if you do it with respect to y. Does that make sense? So
the ones right above the square are in respect to x.
Yep. So but we're doing it with respect to what letter? Y. Look, there's my cross section, guys. This one's on top, the cubic. So instead of saying y equals x cubed, so let me go ahead and rewrite it. Cube root. We're going to say x equals the cube root of y. Do you guys see that? So I'm going to write the cube root of y. Does that make sense, guys? Minus, and look, they're nice to us. The other one, they went ahead and wrote it for us. X equals y squared minus 2. Minus y squared minus 2. Giant parenthesis, dy. Now I need limits. Lower limit is letter b. I'm going to define what b is. Upper limit, we have to use the y value, is what letter did they use? D. Oh man, I made that super small over there. Sorry, I accidentally pushed too many buttons here. Okay, whatever. I'm not messing with that. All right, here we go. Here we go, guys. We're going to get the B, and we're going to get that letter up there. Sorry, because I was about to say something. Okay. Here we go. Here we go, guys. Ready? So I'm going to go second calculate, and I'm going to go number 5. And I'm going to go this black line here and the blue line. Am I in the blue line? I can't tell. Let me scroll. Yep, I am there. Enter. Guess. There's only one intersection. Enter. So now, it was -1. Dang, I didn't need to do that. I guess we could have just looked at it the first time. So it's -1. So I'm just going to erase the letter B and put -1. So that's not a big deal. But here we go. Letter D. This one, it will be something. So I'm going to go second, calculate number 5. And then let's see. What curve am I at? Nope, not that one. That red one. And nope, not that one. That blue one. There's only one intersection. Okay, you see how it says Y there? We did it already earlier. We saved that as a C. But how do we get that Y? So go to the second quit. Go to your window. Do you see the letter Y in green? So you got to push alpha 1 and push enter. And look, there it is. It's saved to that register. So now we're going to go alpha Y, and I'm going to store it. Don't use the letter Y, guys, because those registers are constantly changing. So use a register. That's what they call the letters in technical terms, registers. Use a register that is not being used. So I'm going to go store alpha D. I'm using that letter because they use the letter, right? So enter. So there it is. Cool or not cool? Okay, so give me those digits. Says I write it right here. So I'm going to write D equals, and then give me those digits. 1 point what? $1.793037. One more 7? 715. Like that? 715. All right, there it is. I put as many as I can, guys. And now it's always saved in this letter, in letter D. So here we go. Oh, Chav, how do I type it in the calculator? I don't have these equations. How do I type it in? Guys, we're just doing a hack. It doesn't matter. It doesn't matter what letter we use in the calculator. So I'm going to type in the cube root of x minus parenthesis x squared minus 2. That's what I'm going to type in. So look, here it is, guys. And it's going to be the same. Oh, it might be off a few digits towards the end because we're doing the tolerance levels. All right, here we go. Math 9, -1, all the way to alpha D here. And then I'm going to type in the cube root of y. I'm just doing a hack. Math number 4. Or you can just do, whatever. X. See, there's my cube root of y. That's my hack. Minus, let's see, what did I write? You can distribute the negative, but I'm going to go ahead and use the parentheses. Y squared minus 2. Okay, y squared minus 2. Parenthesis, x squared minus 2. Child, if it's an x, it should be a y. I know, guys. We're doing a hack, you remember? And then putting an x here, and then look, check it out. Was that the same answer as before? Some of the last digits might be off a little bit. Yeah, I can see that they're off after the 9 here. Check it out. Here's the answer up there. 4.21494, and here it is, 4.21493. Child, why are they off? Tolerances and how in the values and all that. So, but see, that's why always to 3 digits, guys. So look, we got 4.214. Let me write all the ones that are the same. 4.2149. 4.2149. What do you guys think? Is this cool or what? You don't like it? Not even a little bit? All right, we're just practicing here, guys. You're just going to use your calculator. It's all calculator work. Check it out. They give you a name for the function, f of x, g of x. You can just use those letters when you're writing out your function. I need to figure out where they intersect. It looks like it's a 1, so we're good. So we got to figure out which one is which. This is a parabola. That's f of x. And then this is your linear line. That's g of x. Cool or not cool? All right. So they want the area in the shaded green from 0 all the way to 1.5. That's x equals 1.5. So here we go, guys. Integral from 0 all the way to, where do those two lines intersect, or two curves intersect? 1. Which one's on top? So f of x minus g of x. Put those in parentheses like that. You don't have to put the parentheses. It's understood that the dx means the end. Plus, where that one stops, the other one begins. Integral from 1 to 1.5. Now which curve's on top? G of x minus f of x dx. Let's add those. I'm going to put this in my f, and I'm going to put this in y1. I'm going to put this in y2. I'm going to put the f in y1. I'm going to put the g in y2. So I'm going to go to my calculator. It's all calculator, guys. Y equals, I'm going to clear everything. Clear. Okay, y1. I'm going to type negative 4x squared plus 9. Negative 4x squared plus 9. And on y2, I'm going to type negative 2x plus 7. Negative 2x plus 7. All right, here we go. Yeah, all we're doing is calculator. Math number 9, 0 all the way to 1. And I'm going to go alpha trace y1 minus alpha trace y2. I'm going to put an x on this. Plus math 9 from 1 all the way to 1.5. And I'm going to go y2, so alpha trace y2 minus alpha trace y1. And then put an x here. Enter. 2.583333. There it is. It says, what did it say? Nearest thousandths? Nearest thousandths. 2.583. Thousandths is 3 digits after the decimal. Yeah, of course. I got you, miss. Heck, yes, we will do. You know what? When we come back on Monday, we'll make Monday a calculator day.
How about 24 hours just like learning? Oh my gosh, like the ways around the calculator. Calculus lost.
Hey, if you guys are down, I'll tell Montalongo.
I'm down.
And
I'm so down.
We'll have pizza. We'll have tacos, calculators. Friday where we do a lock-in. That sounds pretty promising.
I would definitely go.
We'll get Montalongo. All right, if you see Montalongo, tell her that we're starting the initial planning phase. She needs to approve it, right? Because she's the boss. All right. All right, here we go. Let's go to the next one. All right, guys, let's go to the next one. So it says, let the shaded region be the area enclosed by the function f of x equals square root of x minus 2, the horizontal line y equals 0, and the y-axis. Okay. Write an integral in terms of x and also an integral in terms of y that would represent the area of the shaded region. All right, guys, they do not even want the answer. They want you to write an integral. That happens sometimes where they just say write an integral. So here we go. So first let's do it with the respect to x. So here's my curve. That's one of them. That's y equals 0. And here's the other curve. That's called f of x. So I'm going to go integral from 0 all the way to what value? 4. And then upper minus lower. So 0 minus f of x dx. Well, they probably want you to write it in terms of the expression because this is from delta. So they probably want you to write this. 0 to 4, 0 minus parentheses square root of x minus 2 close dx. Giant parenthesis around that if you want that. And there it is. That's it. Cool or not cool? Now we're going to do the y one. Bless you, bless you. Oh, that was a good one. I bet you feel amazing. Okay. Well, I feel amazing when I do a good one like that. Okay. Here we go. Check this out, guys. I'm going to draw a vertical line. There. So you know what's upper and what's lower. Child, what's lower? This line here, that's going to be x equals 0. Because they told me to write it in terms of y, right? Okay. So, yeah, it's f of y now. So I'm going to go integral from my upper. Okay, so we need the y value. The y value way down here is what? And what's the y value way up here? So from negative 2 to 0 of f of y, we don't have f of y, we're going to get it right now, minus 0, upper minus lower. All this with a dy. All right, let's get f of y. So I'm going to write y equals, where are you? Square root of x minus 2. Square root of x minus 2. So what you want, Chop, how do you get f of y? Get x equals something in terms of y. So move the 2 to the other side. So I have square root of x equals y plus 2. And then what do I do to get rid of that square root of x? Square it. So now x equals, and then leave it alone. Leave it like this. This is simplified. So here's my integral. Integral, negative 2 to 0 of y plus 2, close it, squared, minus 0, so you don't have to show that, dy. Do you guys want to type it into the calculator, see if we get the same thing? I kind of do. Yeah, look, don't worry. Let's just look real quick. Check it out, guys. You guys can just bear with me. Math 9, let's do the x one first. 0 to 4, I believe. And then I had a negative on the outside, parentheses, and then I had square root of x minus 2. Okay, so check it out. I'm going to go math. Actually, I didn't need to do math. I can just type square root. So here we go. Sorry, guys. Square root. Second, square root, x. Get out of there. And then what was it? Minus 2. Minus 2. And there it is. And just push x here. Enter. There's my answer. There's something funny going on. That 456 is not 456. It's 2.666 forever. All right, let's do the math. Let's do the y one. Math 9. Negative 2 to 0. Let's see if we get the same thing. And I'm just doing a hack. I don't have a y. I guess I could type the y, this y, but it's just easier to just use this, guys. And I'm going to type in y plus 2 squared. So I'm going to type x plus 2. Parenthesis, x plus 2, close it, squared. Check it out, guys. Check it out. Look at this. Same thing. You don't get it?
Yeah, I do.
Oh, who would have thunk it? Okay. What do you guys think? Not bad, right? All right. Take a 5-minute break. In a little bit, you'll get a delta. It'll be live. You can just use calculators, and there it is, guys.